Good afternoon, folks. This is Mike coming back at you with another video on Foundations of Math 2. In this video, we are going to shift to a little bit of a different, yet still very, very important topic in the world of statistics. We are going to talk about measures of average. So in the world of statistics, we often wish to find the average or something that we can reasonably work with as the average for a set of data. So we're going to look at the various measures of average, but more commonly referred to as the measures of central tendency that we have. And we're going to see how we calculate them and how we actually find them. In later videos, we are going to see certain other measures that measure other things related to the measures of average, yet also perhaps not related to the measures of average. We're going to be talking about measures of difference and measures of position as well in later videos, and we're going to see how these things kind of sort of tie in with each other. But the first measure of central tendency, or the first measure of average, is the mean, which is just a nice mathematical word for the average. Now, you may say, okay, so we have something called the average. Are we really going to even bother messing around with finding any other measures of central tendency? Yes, we are. And by the end of this video, we'll see why we bother with finding these other measures of central tendency. But first up, the mean. If you have a set of data, it has these values, and let's label each of these values, call them x1, x2, x3, x4, all the way up to and including xn. So in total, we have n values. The mean of this set of numbers, or the set of data, is x and then a horizontal line over it, and we read that as x bar. So the mean x bar is simply the sum of each of your values divided by the total number of values there. And we have a special mathematical symbol that we use to stand for the sum. Maybe some of you have seen it, maybe you haven't. But this thing here, this sort of funky looking capital E, this is called sigma. Specifically, it's a capital sigma. And we typically use this capital Greek letter to stand for the sum. We're taking the sum of these x values. So we're going to take that whole sum, and then we are going to divide that sum by the number of data values that we had. So that's the first measure of central tendency. The second measure is the mode. The mode of a data set is simply the value that occurs most often. Now, it is possible for there to be more than one mode. Perhaps there are two values that occur most often, and they occur the same number of times. It certainly is possible to have a mode there, or it is certainly possible to have more than one mode. If each data value only shows up once, then typically we say that there is no mode, because there's not something, or there's not one or two or so particular values that occur most often. They all only happen once. So that's the mode. In some ways, this is the easiest measure of central tendency to find. The third measure is called the median. The median should be thought of the middle value of the set of data. And really what the median does is it takes your data set and it sort of splits it in half. Half of your pieces of data are less than the median, and half of your data points are greater than the median. And there's a straightforward two-step process that I highly, highly, highly recommend that you use to determine the median. In fact, it's so highly recommended that it's basically required. First thing you're going to do is you are going to rearrange the data so that the values are in increasing order or they are in decreasing order. Doesn't really matter which one you do. And really just for any set of data where you have to find any of these measures of a central tendency, frankly, I would suggest that you do this just because this will help make finding the mode be a lot easier as well. So once you have all of your data values in increasing or decreasing order, you then look at the number of values that you have. If the number of data values is odd, then the median is the value that's going to be in the middle of your set. You'd have some number of data values less than the median, and you'd have the same number of values of data that are greater than the median. So if you have an odd number of data values, that's nice. If the number of data values is even, then the median is simply going to be the average of the two middle values. So say we had a data set that had, say, 10 values or so. The middle two data values will be the fifth and the sixth. If you take the average of the fifth and the sixth values there, when they're in increasing or decreasing order, that average is going to be your median. The other reason why it's good to have the data in increasing or decreasing order is because it makes it very easy to find the fourth measure of central tendency, which is the mid-range. And the mid-range is simply the average of your highest value and your lowest value. Mid-range is lowest value plus highest value. That sum divided by 2. So we have 4 measures of central tendency here, mean, median, mode, and mid-range. All of them are M-words. So we are going to do a couple practice problems here with some sets of data. We're going to find each of these measures of central tendency. We're going to find the mean, median, mid-range, and mode. So first problem, the number of assaults for the 11 largest universities in Ohio in 2016 are listed below, and we're going to find those 4 measures of central tendency, or measures of average. So first thing I would recommend that you do, I'd highly, highly, highly recommend, again, basically just do it, is put your data in either increasing or decreasing order. I'm going to choose to go increasing. That's just my personal preference. You can certainly go decreasing if you want. So looking at my values here, the lowest number I have is a 2. And once you've placed the data point in its new order, just cross it out from your list here, and then you'll have all those values crossed out, and they'll be put in the order that you want to work with down here. So next I have 3. Next number up from 3, there's 7. I have 3 5s. Then I have 2 7s. Then I have a 14, a 16, a 20, and a 30. So I've just taken all my data values and I've put them in increasing order. So now we can look at our data here, and we can nicely find what some of these values are. So mean, median, mode, and mid-range. The mean, we said, is simply the sum of all of our values divided by the number of values that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 values, as it said in the question right there. So I'm going to add up all these numbers here. 2 plus 3 is 5. 5 plus 5 plus 5 is 15. Again, you can type in each number on your own. I'm just taking some smaller sums and making things nicer for myself to plug in. So that sum there, this is what the mean is, just having all of our data values listed, divided by 11. That sum was 114 divided by 11. And if you do 114 divided by 11, you get approximately 10.363636. And that pattern of 3, 6 repeats. The question may specify to round to some certain number of places. If it does specify, then round as they require. All right, the median. Now that we have our data in increasing order, we said we have 11 pieces of data. So we have an odd number of pieces of data, so that's perfect. This means that the median is going to be the data value that falls exactly in the middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the middle value is going to be the 6th, because we're going to have 5 values less than that, or to the left of it. We're going to have 5 values to the right of it. So our median, or our middle, is going to be 7 right there. For that, to find the median in general, just kind of straightforward overall. Just see, okay, what's the number, or what's the place where I have the same number of values of data to the left and to the right of it. The mode is, again, the data value that occurs most often. Looking at my data here, I see that I have 2 7s, but I have 3 5s. So 5 is what occurs most often. So 5 is going to be our mode. And then lastly, our mid-range, we said was the average of the lowest and the highest value. So 30 plus 2 all over 2 equals obviously 32 over 2, or 16. So there we go. We have our mean, we have our median, we have our mode, and we have our mid-range. So there's our first sample problem with finding these 4 measures of central tendency. Going on to the next problem. A graduate student surveyed students at 10 colleges to see how many are single parents. The results are listed below. Again, we're going to find the mean, median, mid-range, and mode. So once again, let's just start by putting our data in either increasing or decreasing order. I'm going to do increasing personally. So pause the video, do that now, and once you have it in the order which you prefer, press play, and we will continue on. Okay, so I have taken my data. I've put them in increasing order. Just as a quick note, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of data here. So again, kicking things off with finding the mean. I'm taking the sum of all these numbers, and I am going to then divide that sum by the number of data values that I had, which is 10. So 260 plus 270 plus 280 plus 298 plus 380 plus 570 plus 638 plus 700 plus 1350 plus 1380. That sum is 6,126. And if you divide that by 10, you get 612.6. Make that first 6 there very clear. So 612.6 is going to be our mean. Going with the median now. So here we have an even number of points of data. So this is the case where we're going to take our two middle values and we're going to take the average of them. If we have 10 pieces of data, the middle two numbers are going to be the numbers in the 5th and the 6th spots. So I'm going to take the average of, in this case, 380 and 570. 380 plus 570 divided by 2. 380 plus 570 equals 950. Divide that by 2, and we get 475. So there we go. There is our median value. This value does indeed split the data set in half. Half of the values are less than 475, and half the values are greater than 475. Technically, with our previous sample, does the median actually split it in half, in the sense that exactly half of the pieces of data are less than the median and half of them are greater than? Not technically spot on half, but nonetheless, that is what we do when we're finding the median for a data set that has an odd number of values. The mode. Again, the mode is the value that occurs most often. But if we look at our values here, there isn't any value that occurs more than once. Every value only happens once. So this is a case where we would say that there is no mode. You could say none, you could say NA. Something to show that there isn't one. And then lastly, our mid-range. Again, the mid-range is simply the average of the smallest and largest values. So 1380 plus 260, that sum divided by 2, and pulling out your calculators. If you do that average, you get 820. There. So there is our mid-range for this set of data. So these have been a couple sample problems where we get some practice with finding the mean, median, mid-range, and mode. As you can see, there's really not any super complicated calculations going on here. It's very simple, very straightforward, very basic things that are happening here. Now, sometimes we have data that is put into classes. When we saw things where we took data and we made, say, a grouped frequency distribution or a histogram or something like that, we had data in sort of classes. Sometimes we do need to get some sense as to what the mean is for data that is put in classes. So the question is, how do we do that? Well, the way we get some sense of what the mean is we find the mean by adding up the product of the frequency of the class, or the frequency of each class, and the midpoint of that corresponding class. So for each class, you're going to have some kind of frequency. You're going to take the midpoint of that class. You're going to take that midpoint and you're going to multiply it by the frequency that's associated with that class. You're going to do that for each class and frequency pair. Take those products, you add all them up, and then you're going to take that sum and you will divide that sum by the sum of the frequencies that you had. So here are a couple sample problems to see how we do that. So first up, 100 students in a student union were surveyed about their age, and the results are shown below. We're going to find the approximate mean of this data set. And we see that we've broken the ages down into classes, 18 to 20, 21 to 23, 24 to 26, all that. And then we have the frequency associated with each class. Note that the sum of the frequencies is indeed 100, the number of students that were surveyed. So here's what we do for the mean. We're going to have a whole long sum on the top. So as I said, we take the midpoint of a class and we multiply it by the frequency that's associated with that class. So if I look at the class of 18 to 20 years old, the midpoint of 18 to 20 is 19. So I'm going to take that number 19 and I'm going to multiply it by the frequency for this class. That's going to be one of my products. Next class, what's the midpoint of 21 to 23? Well, that's pretty nice, it's 22. I'm going to take that midpoint of 22 and I'm going to multiply it by the frequency for this class, which is 29. And I'm going to keep doing the same thing for each of my other four classes. Take the midpoint, halfway between 24 and 26 is 25, multiply it by the frequency. Halfway between 27 and 29 is 28, multiply it by 9. Halfway between 30 and 32 is 31. Multiply that by 3. Halfway between 33 and 35 is 34. Multiply that by the frequency of 7. And I'm dividing this whole thing on the top here by the sum of these frequencies, which we said was 100. So now we have some fun calculations to do. And through the magic of working with videos and pausing things and cutting things out, I have found each of these products here: 684, 638, 400, 252, 93, and 238. I'm going to add those numbers up and then divide by 100. And through more video magic, I've taken the sum and I have divided by 100, and in the end you come to 23.05 years, or approximately 23 years. So this is an estimate as to what the mean is. We stress that this is an estimate because we don't know exactly how many people there were of each age within each class. Perhaps for the 18 to 20-year-olds, perhaps there were more 18-year-olds than 20-year-olds. Perhaps we had 35 18-year-olds and only one 20-year-old. We don't know for sure. The data was just given to us in these classes. So this is why we stress that this is an estimate for the mean, not the sort of surefire mean. So second problem, I want you to try on your own. Do the exact same thing, but with this new set of data that you're given here. Again, find the midpoint of each class and multiply the midpoint by the frequency for that class. You take those products, add up all those products, divide that big sum by the sum of the frequencies, which in this case is 40. You can see that all those numbers will add up to 40. So pause the video, try to figure this problem out on your own. Once you think you have it, press play, and we'll see if you were correct. All right, so here is what you should have gotten. Again, we took the midpoint of each class. Their midpoint should have been 10, 15, 20, 25, 30, and 35. Multiply the midpoint of the class by the frequency for that class. That gets you this top part here. And I'm dividing by the sum of my frequencies, which is 40. Each of your products here are these numbers right here at the top. Add all those up, you get 10, or not 10,040, 1,040. And if you divide 1,040 by 40, then you get 26. And the context that our data was in was that this was the fuel efficiency for 40 new cars. So fuel efficiency is measured in miles per gallon. So 26 mpg. So hopefully you came up with 26 as your final answer. If you didn't, take a look back through your work, see where you are, and try to see where things went off. But these have been our couple sample problems with finding the mean for a set of data that's already given to us in classes. So at the beginning of the video, we stated what the various measures of average or the measures of central tendency were, and I said that I would get to why we don't always just use the mean, why we don't always just use the average. So when do certain measures of central tendency best represent the true average? Well, in most cases, we will use the mean to serve as the average, or what we want to work with as the average for the set of data that we have. But there are cases when using the median or the mode may be better to use. The median is better to use when the data set contains a value or values that vary greatly from the others. We have a term for this that is referred to as an outlier. Also, the median is best if there are some missing or undetermined values in the data set that you are gathering. Maybe you're doing some kind of survey and you survey some folks and they're not really sure as to what the actual number is that you are searching for, or just something's not really clear, or you feel that something isn't quite right with a couple of the values that you receive. But an example of an outlier would be, say, that you had a data set that looked something like this. 9, 15, 11, 6, 1, 2, 3, 8, 14, 10, 11, 10, and then say 112. You know, all of these data values right here, these are all staying fairly close to each other. We have numbers going from 1 to 15, and then we have 2s and 3s and 6, 8, 9, 10, 11, 14, 15. So those are all sort of staying within their own little group or their own little cluster sort of there. But then you have this value of 112, which is way, 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 way larger than the largest value in your other group here, which is 15. You know, this is significantly, significantly larger than everything else. And if we try to calculate the mean for these values that we had, including this value of 112 would drag the mean way up compared to what the true average might actually be for the context that we are in. So having a value that is significantly larger or smaller compared to the other data that's all kind of hanging near each other sort of, that's going to drastically impact the mean if we were to calculate it. So going with the median rather than the mean would give us a better sense as to what the true average is going to be. The mode is better to use when the data that you gathered is on a nominal or a name-based scale. Cases where this might happen, say you're at a doctor's office and you fill out that little survey of what's your pain level in, say, the various parts of your body, like head, eyes, nose, neck, shoulders, arms, legs, back, all that, and maybe they have sort of a choice of mild, moderate, or severe. If we were to look at those values, I put in air quotes values, that we got, things, you know, the values that happen most often, that would give us sort of a nice sense as to what the true average is. Or things where maybe you have a word and then they associate a number like 1, 2, 3, 4, or 5. You've probably also seen surveys where they ask you your thoughts on some product or some service, and for each question you have the option of poor, below average, average, above average, and then superior or something like that. You know, those kinds of surveys and the data that you get from those kinds of surveys. That's all stuff that's on a nominal or name-based scale, and the mode is really what you would want to use there to get a true sense as to what the average person is saying about your product or your service. So this concludes our somewhat lengthy video on measures of average and measures of central tendency. In the next video, we are going to be talking about some new measures of variation and or measures of difference. We're going to talk about the range, the variance, and the standard deviation. If you have any questions or comments, please be sure to reach out to me, guys. Emails, texts, voicemails, whatever you need to do. Until the next video, take it easy, guys.